Just wanted to make this recording for the document I posted on Blackboard. This is just a basic document. You're still going to have to do a lot of work with it. Basically all I've done is organize it. But you see we've got original data here, up to 30 different entries. Just copy and pasted our our data onto this other sheet here, from which we're looking for a linear model, for example. We're going to calculate slopes based directly on the original data. If we're looking for an exponential model, we're going to calculate those slopes using some of the logarithmic data. And power model the same. So again, this is more of an organization than anything else, but we can go ahead and start calculating these slopes. This first one, actually, start here. This first one, take the y value minus the one before it, divided by the x value minus the one before that. Whoops. Telling me I need another parentheses. Go ahead and accept it, extend that down, and then from here we can go ahead and figure out what the average average slope is. Auto sum, you can average it. Looks like negative 3.43, 3.44 is our average slope. Then we can ask ourselves if that seems to fit with the data itself. We go ahead and plot that data over here. So we've got access to it. If that seems to fit the data itself, then we can go with it. If not, we could try something different. Okay. Either way, we're going to be looking at the linear model here. So our slope, at least to start with, I'm going to enter in negative 3.34. Okay. Go ahead and make these readable. The starting y value is going to put us somewhere up here, probably. Let's say 50. We can adjust it from there. And the equation for the linear model, it's going to be what? Y equals the slope, which is going to be h3. Oh, let's put it down here. Y equals slope times the x value associated with this slope we can find directly over here. So that's a4. Add to it our y-intercept, which is I3. Okay. Oops, sorry, I4. I want all this to be on the same line. This you can see is h3, so it's going to go ahead and take this value. So I want to make that h4 as well. So again, notice I've got everything on the same line. 1, 2, 3. We go ahead and hit enter here. We get a value and then carry that value all the way down to the end of our original data. Now I need to see if this makes sense with our graph, so I'm going to add a series to our chart. That series, the series name, let's go ahead and call it the linear model. X values are going to be our original x values, and the y values are going to be right there. Hit go and see if they work. We see that all these values are going to be below our original data. I'm going to do one other thing. Let's see, format the design. I want to go ahead and make it one of these charts for our models. This will be helpful because we don't really care what those points are as far as determining if this fits the data or not. We just care what that line is. So that line is significantly below our data, so I'll go ahead and change the y-intercept, see if we can bump that up a little bit. Y-intercept of 50. Indeed, it does bump it up. We can keep going until it makes a little bit more sense. But now I notice that the slope seems to be off. Here it seems like it's decreasing much more slowly than our linear curve appears to be. So I'm going to make this slope decrease more slowly. That is, I'm going to make it approach 0, or make it closer to 0. And that does, in fact, mimic our data a little bit better. So let's say this is the linear model that we want to go with. Go ahead and copy these. Go back to our other sheet. Excuse me, and paste them. Notice it's pissed off about the reference. Okay, we've got an issue. Like, go ahead and delete. Oops, doesn't matter. Get rid of those. We got to change something. I got to go back here and copy it. Make sure when you paste it, you're going to paste it special. So that's a right click. Paste values. That's just going to paste those numbers from the previous sheet. And then we can see that indeed those dots have been added. So that's just an example for our linear model. Again, note up here, enter the calculations from the other sheet in this row. Basically what I want to see right here in this row is how you calculated that linear model. Linear model, it's not too exciting. With the exponential and later power models, it's much more exciting. There's a lot more going on. Now as far as this chart's concerned, we don't really need it anymore. You can go ahead and put it down below with whatever title we have, or you can go ahead and move the chart, move it either to a new sheet completely or make it an object in a different sheet. Okay. We don't have a sheet for it, so I'm going to go ahead and make it on its own new sheet. The downside to this is when you print it, you're going to have a full page of paper for that one graph. But it doesn't matter. Again, this is mostly for calculations. This sheet will be where all the interesting stuff occurs. Okay. So back to here. Now I want to go ahead and work with our exponential model. Or let's go ahead and work with the power model. Okay. That's where we have to take log of both the x and y values, and log of both of those should give us our line. So log 10 of this one. Over here I'm going to have the same thing. Don't want log, I want log 10 of this one. Both of these are log 10, so I'm just going to pull this down here. And we can verify that indeed log 10 of B7 is right here, B7 is right there. So it did take the correct logarithm. Now, we've already got some calculations over here. I'm going to copy and paste these. Not paste special, just regular paste into this column. We can verify that indeed each of these will go ahead and paste exactly the same calculation for slope that we had earlier. Now, this won't work for exponential. If you'll recall, for exponential, we're going to take the log of the y values, and the x coordinate for that graph is not going to be log x, but rather the original x coordinate. So if we're working with the exponential model, you have to do a little bit more work to take these two values, the difference between these two values, divided by the difference between these two values, not the logarithm values. But you can figure that out on your own. Verify that indeed this is the average of those terms, and it is. Okay, so that's going to be my starting slope. My starting slope up here, I'm going to have negative 6.11. Again, go ahead and make these visible here. And we're not going to be able to tell what's happening until we go ahead and get our curve visible, or our points visible. So I want to insert, go ahead and insert a line like that. So this is our original data, has this shape. Sorry, not the original data. Our logarithms have this shape. So we want to go ahead and see if we can come up with a slope or a line to mimic this data here. Okay. First off, if you recall, with a power model, an actual power model, when you take the log of the x values, plot it against the log of the y values, you should have a straight line if the model or the data is able to be predicted by a power model. In this case, we don't have a line, so this is probably not a power model, but we should still be able to come up with a model, whether it's good or bad, for this function. So, we've got this curve here. We just need to come up with, do the same process we did for the linear model, to try to come up with a line that'll go through it. Looks like 1.8 is the top end there, so we'll start our y-intercept there at 1.8. Enter the equation here. Go ahead and skip. And that's going to be equals, I want this to be visible, sorry. So this is going to be equals, well, it's just a line. So again, slope is right here times the x value. Now I'm trying to find a model for this right now, a linear model for this, so my x value on that curve is over here, log x, plus our y-intercept, which is going to be right next to it. Hit go, and we'll have some stuff plotted. I'll drag this down so we have a little bit more going. And lastly, I'm going to go ahead and add a series here. The x values, again, that we're trying to mimic are right here. The y values then, repeat those of our line. And we get this. Okay? Doesn't look like it fits at all. So, first step, I'm going to go ahead and change this y-intercept. Maybe let it be 3. See if that helps. It does not. But we see that this looks a heck of a lot more shallow than our line is. We'll go ahead and change that slope. Still a negative slope, but that negative slope goes from about 2 down to, well, a little bit more than 1, so a little bit more shallow than 2 over 1. So we'll go with negative 1.5. Try that. Okay. And that looks like it mimics it a lot better. This is much closer than we were. Now I need to bring this y-intercept back down, see if that helps. And we've got a decent little model. Okay, it's not the best, but again, we said this is definitely not a line. So we know we're not going to have the best possible model. On the last column, under exponential model values or the power model values, that's where I want you to actually enter in the values for your exponential or your power model. So that's going to be based on the notes from class or in your textbook, where for example, with the power model, the y-intercept of the line values, or of that line, the y-intercept is the log of that variable c, or the coefficient on the power model. So make sure you're entering those in on that last column of each section. Secondly, when you're checking those, remember to check those with a chart for the original x values and those model values. So again, for the last column in each section, you're going to create those models based on your notes from class or from your textbook, and graph those to check and see if they're decent models using, first off, the original x and y values from your data, and plot those with the exponential model, which would be x values from your original data, and the y values would be those exponential or power model values.